Students, in probability chapter, we have learned what is the basics of the probability, how we can use addition theorem and where we can use addition theorem of the probability, and what is the modified form of the addition theorem of the probability. Similarly, in today's video also we will learn some new terms related to the probability, and that is a multiplication theorem of the probability. When two events or more events are free with each other, it means that if events are independent, then we use multiplication theorem of the probability. The events independent means the one event does not having any effect on second event, then we will say the events are independent. And in such kind of the condition, when the events are independent, we generally use the multiplication theorem of the probability, and that is probability of A intersection B, that is called probability of A multiplied by probability of B, or we can say probability of A and B, that is also probability of A multiplied probability of B. It means when you got intersection, you have to use multiplication theorem. When you find any AND word, then also you have to use multiplication theorem of the probability. If the events are 3, suppose the probability of A and B and C is to calculate, then the probability of A multiplied by probability of B multiplied by the probability of C. Or we can say the probability of A intersection B intersection C, so that is the probability of A multiplied by the probability of B multiplied by the probability of C. It means the multiplication theorem of the probability we will use in such kind of the condition where the events are independent with each other. Suppose I am throwing a coin in 3 times. One times I am tossing a coin, second time I am tossing the coin, so the second time I am tossing the coin are independent with the first time. Whatever in first time I have got, no problem at all. The second toss is not having any relation with first one. So in such kind of the conditions, suppose I am throwing a dice and I got 6. Againly I am throwing the dice. I can get 1, 2, 3, 4, 5, 6. So my second throw is not having any relationship with the first throw. Similarly, in box contains 5 red ball and 5 black ball. One ball I pick at a random, and this is black. I put againly in this box, and againly I am picking a ball from the box. So the second I am picking the ball from the box haven't any effect with first event which happened. So in such kind of the condition, when the events are independent with each other, then we will use the multiplication theorem of the probability. In this video we will having some question related to the multiplication theorem of the probability. So you may learn how to use this multiplication theorem of the probability. First I am having 5 or 6 question in this video, so you may be having the now how to use this multiplication theorem of the probability. A coin tossed 3 times. What is the probability of getting all 3 hit? The first question is, one coin tossed 3 times. What is the probability of getting all 3 heads? So the first probability of getting first head, that is 1 by 2, because in tail and head 2 events is over there, and favorable event is head 1. In second event, second toss is totally independent with the first event. Suppose in first game, if 3 cricket match is over there, in first match a captain won the toss by asking head. So the probability 1 by 2. In second toss also, if we want head, so the probability of 1 by 2. And third throw also, if we want head, so probability of 1 by 2. So probability of A and B and C, that is probability of A multiply by probability of B multiply by probability of C, or we can say the probability of A intersection B intersection C, that is called probability of A multiply by probability of B multiply by probability of C. So if a coin toss 3 times, the probability of getting all 3 head, so first head probability is 1 by 2, second head probability is 1 by 2, and third head probability is 1 by 2. So the probability of getting all 3 head will be 1 by 8. So in this event, the first toss is free, second toss is free with first toss, third toss is free with first or second toss. So we will say when the events are totally independent with each other, then we will use the multiplication theorem of the probability. One more question related to this. If two dice thrown simultaneously, if I am having some questions related to the multiplication theorem of the probability, one dice thrown 2 times, what is the probability of getting that in the first trial it will be a number of 5 and second time it will be a even number. So one dice thrown at 2 times, in first 5 is over there. Againly you should listen the question. One dice thrown 2 times. What is the probability that in first throw it will be a 5 and second throw it will be a even number? So in first throw, the getting 5 is 1 by 6, because the in dice 1, 2, 3, 4, 5 and 6 are total numbers, and getting 5. And in second throw is free, totally independent with the first throw, because in first throw you get 5, that doesn't affect in second throw what you will get. So in second throw, for getting even number, that is 3 upon 6, because even number is 2, 4 and 6. So for probability of getting A intersection B, that is called probability of A multiplied by probability of B. So that will be 1 by 6 multiplied by 3 by 6, that is 1 by 12. So in this manner, we can use the multiplication theorem of the probability. One more question related to this. Two dice thrown simultaneously, 2 dice thrown 3 times. A pair of 2 dice thrown 3 times. What is the probability in the first throw? There will be addition of 10. In second throw, there will be addition of 11. And in third throw, there will be addition of 12. So the pair of pair of 2 dice is thrown. The probability of getting in first thrown, the probability of getting 10. In dice 6 multiply 6, total event will be 36, because 2 dice is over there, so the total event will be 36. Already we have gone the example of this, that is 1 1 1 2 1 3 1 4 1 5 1 6 1 7 up to 6 1 6 2 6 2 3 6 4 6 5 6 3. Already we have learned if 2 dice thrown simultaneously, the event will be 36. Okay. For getting in first throw, getting the addition of 10. Addition of 10 is possible, 5, 5, 6, 4 and 4, 6. So the first addition of 10, that is 3, is favorable event, total number of event is 36. In second throw, the addition of 11 is over there, so there may be 2 possibility, 5 in first, 6 in second, or 6 in first and 5 in second. So the probability of second event, that will be 2 upon 36. And probability of getting addition of 12, that is 6 and 6 in 6 in first and 6 in second. So the probability of C event, that is 1 upon 36. So probability of getting A intersection B intersection C, that is called probability of A multiplied by probability of B multiplied by probability of C. So that will be 3 upon 36 multiplied by 2 upon 36 multiplied by 1 upon 36. So we were having 6 6 are 36. So the addition of that will be 36 multiply, that is 1 divided by 7 7 7 and 6. So in such kind of the question, two dice thrown simultaneously, the very first probability of getting 11 10, then second throw are totally independent with the first throw, so there will be 2 upon 36, and third throw also independent with first and second throw, so 1 upon 36 is over there. Because all throw are independent with each other, so we will use the multiplication theorem of the probability, that is probability of A or B or C, that is probability of A multiplied by the probability of B or multiplied by the probability of C. Some more question related to this we are having. One more question related to this multiplication theorem of probability. One bag contains 5 red ball and 4 green ball. One bag contains 5 red ball, 4 green ball. Okay. We bring 3 balls 2 times, and in second trial we keep our balls right againly in the bag. What is the probability that in first trial all 3 will be red and second trial all 3 will be green? Againly I am repeating the question. One bag contains 5 red ball and 4 green ball. 3 balls, I am repeating. 3 balls are drawn twice. Before the second draw, the ball replaced in the bag, find the probability that in the first draw the ball will be red and second draw all the ball will be green. So there are 9 ball is over there. In first picking the ball, 3 ball is picking, the probability of getting red. So the first trial getting red, that total number of event is 9C3, and getting 3 red out of 5 red, that is the probability 5C3. Again listen, the total number of balls in the bags is 9. 3 balls drawn at a random. So the total chance of the getting 3 ball out of 9, that is 9C3, and the probability of getting all these 3 balls are red, so the probability is 5C3. So for solving this, we are having, that is 5 multiply 4 multiply 3 multiply 1 multiply 2 multiply 3 divided by 9 multiply 8 multiply 7 divided by 1 multiply 2 multiply 3. 1 2 3 to 1 2 3 cross. 4 2 ja 8. 3 3 ja 9. So there will be 5 divided by 3 multiply 2 multiply 7. So the probability of getting red balls, that is 5 upon 42. Now ball is replaced againly ball replaced in the bag. So now againly the bag contains 9 balls is over there. For getting green balls, so the total number of event is 9C3 and the green event is 4C3. So solving this, 4 multiply 3 multiply 2 multiply 3 multiply 2 multiply 1 divided by 9 multiply 8 multiply 7 multiply 3 multiply 2 multiply 1, this cross to this. 3 3 ja 9, 4 2 ja 8, so 2 upon 42. So probability of red and green, that is called probability of red multiply the probability of green. So that will be 5 upon 42 multiply 2 upon 42 and having 21. So that is 42 multiplied by 21, that is 5 divided by 882. So in this question we should learn one box contains 9 balls, one times we are getting 5 red balls, 3 red balls. So there will be total 9C3 and getting all 3 red, that is 5C3, and the solution of this contains to 3 times, so 5 multiply 4 multiply 3, 3 multiply 2 multiply 3, 9, 8, 7, 3 times we have written, and 1, 2, 3. In similar also, that is 4C3 divided by 9C3, so that is 4 multiply 3 multiply 2 divided by 3 multiply 2 multiply 1, and 9 multiply 8 multiply 7 divided by 3. How to solve this? See, we have learned in the permutation and combination chapter. If you don't know how to solve this, here you can go through with the some of the video, which the link of this video will be given by me in the description box. So you may learn how to solve 5C3. First, one time I explain you here that NCR is factorial n upon factorial n minus r and factorial r. So here 5C3 is over there. So that is factorial 5 upon factorial 5 minus 3 and factorial 3. So here the 5 multiply 4 multiply factorial 3 divided by factorial 2 multiply factorial 3, factorial 3 to 3 cancel. So that will be 5 multiply 4 multiply 2 multiply 1, so that will be 10. So the value of 5C3, that is 10. So if you will go with the permutation combination chapter, you will learn how to solve this here. Here only you should learn how to solve this, that is very simple. Suppose you are to solve 9C3, so write here 9, 8, 7, write 3 here, so 1, 2, 3, no problem at all. Now come to the another question we are having. Suppose one bag contains 5 red and 4 green ball is over there. 2 balls drawn at a random. What is the probability that 2 times 2 ball is drawn at a random? What is the probability that the both ball will be different color? Okay. So getting probability of 1 red or 1 green. So the total number of event is 9C2 and getting 5C1 is red and 4C1 is green. So this is 5 multiply 4 multiply 9 multiply 8 multiply 1 multiply 2, so that 4 to 4 cancels, so 5 upon 9. If we put both ball in againly in bag and drawing 2 more ball from this bag, againly we are want to now that 1 red or 1 green ball is over there. So there also 5C1 multiply 4C1 upon 9C2, so that is 5 upon 9. So getting probability of A and B, that is called probability of A, multiply by probability of B, that is 5 upon 9, multiply by 5 upon 9, that is 25 upon 81. In this question, 2 times 2 balls drawn at a random, and with replacement, it means in second time when we are drawing 2 balls, the first 2 balls againly put in the bag. So in first, the probability of getting different color, so different color is 1 red and 1 green, so 5C1 and 4C1 divided by 9C2, so the probability of that is 5 upon 9. Againly we are putting both ball in the bag. So now the probability will be same, picking 1 red or 1 green, there may also 5C1 multiplied by 4C1 divided by 9C2. So that will be also 5 by 9 by 2. So probability of getting A event or B event. So what we have said, if AND is over there and intersection is over there, we have to use the multiplication theorem of the probability, because both events are independent with each other. So we will use this theorem. Again, one more question related to this. One more question we are taking. One bag contains 3 red and 2 green balls. One bag contains 3 red ball and 2 green ball. Okay. One bag contains 3 red ball and 2 green ball is over there. Find the probability that the first drawn will be red, second will green. Find the probability that first will red, second will green, third will red, fourth will green, fifth will red. Again, listen the question. One bag contains 3 red ball and 2 green balls. Balls are picking one by one without replacement. It means one ball is picked, that there will be no replacement is over there. So what is the probability of getting the first ball will be red, second one will green, third one will red, and fourth one will green, and last one will be red. So for probability of getting red ball, so 3 upon 5, first red. Second, now the ball is 4, so getting green probability is 2 upon 4, because the green is available 2 and total is 4. Now we have got the green here. So third times total balls are in the bag are 3 and the red are 2. Now getting red. Now 2 balls are in the bag. One is green and one is red. So getting green is 1. And last one ball in the bag, and that is red. So that is green and that is red. So solving this, 2 cross by 2, 2, 3 cross by 3. So 1 by 5 multiplied 2, that is 1 upon 10. So the probable answer will be related to this, that is 1 upon 10. Okay. One more question. From a pack of 52 cards, from a pack of 52 cards, a well-separated 52 cards distributed to the 4 players. What is the probability that one particular player will get all 4 kings? Again, I am asking, repeating the question. A well-suffered pack of 52 cards distributed in the 4 players. What is the probability that one particular player will get all 4 kings? So in pack 52 card is over there, and these 52 cards, if distributed in the 4 players, each player will get 13 card, 13 card, 13 card and 13 card. So for total probability of getting 13 card from the 52 card, that is called 52C13. Total number of event is 52C13. Because there is a pack of 52 card and we are distributing among the 4 players is over there. So each player will get 13 cards. So the total events, number of event will be 52C13. Now the one particular player will get all 4 king. So that will be 4C4, and remaining from 48 cards, he will get 9. Total he is getting 13. So 4C, 48C, 9 is over there. Okay. If well-supported pack of 52 card is over there. So there are 4 players, so the one player will get 13 cards, so the total number of events will be 52. C 13 is over there. Now one particular player are getting 4 cards, all 4 kings is over there, so 4 C4 and 48 C9 is over there. So we will solve this that is 4 C4 is 1, because n, the value of n C n is equal to 1. Now related to 48 to 48, multiply 47, multiply 46, multiply 45, multiply 44, 43, 42, 41 and 40. 9 times you have written 1, 2, 3, 4, 5, 6, 7, 8 and 9. Divided by 9, multiply 8, multiply 7, multiply 6, 5, 4, 3, 2 and 1. That is 48 C9. So we have written 9 times here. Divided by 13, so 52, multiply 51, 50, 49, againly 48, 47, 46, 45, 44, 43, 42, 41 and 40. Divided by 13, multiply 12, multiply 11, multiply 10, then 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. So this is 9 times, so we have 9 times here, 9 and 8. This is 13 times, so we have written 13 times. Now come to the 9873, 9873 cross. 48 to 40, cross by 48 to 40. So this will be 13 multiply 12 multiply 11 multiply 10 divided by 52 multiply 51 multiply 50 multiply 49. Just we have to solve this. 13 4 ja 52. Okay. 10 5 ja 50. Okay. 4 3 ja 12. 17 3 ja 51. So that is the probability of that is 11 multiply by 7 multiply 5 multiply 17 multiply by 5 multiply by 49, that is 4165. So answer will be 11 upon 4165. So in such kind of the condition, when the events are independent, then we can use the multiplication theorem of the probability. So I think this video will be helpful for you to know how to use multiplication theorem of the probability. In next video also we will discuss the multiplication theorem of the probability. Thank you once again.